What's popping, fam? Welcome to another spicy LP3 practical video. In this video, we will take a look at all the machine learning assignments. And since I had my practical today, I will try to share some ways you can improve your answers based on my experience. These are the programs that we are going to focus on today, all the way from program 6 to 10. Before we start this video, please consider subscribing as it's free and it encourages me to make these videos because YouTube pays me nothing, lol. In the Uber fare prediction, the problem statement goes as predict the price of an Uber ride from given pickup point to the drop-off location, and we have to perform these tasks like preprocessing, outlier identification, correlation checking, and in regression and random forest models implementation. And also we have to look at the scores like R2 and RMC. We will first import all the required libraries and load our dataset. The Uber fare dataset used here is sourced from Kaggle and is mostly the same as the one used in the practical examination itself. Let's just check for null values, and I've removed some features including the fair amount for now. We'll add the fair amount later, but the unnecessary features are removed. We've dropped all the null values over here. Then we will now write the Haversine formula, which is used to calculate the distance between the given latitude and longitudes. Since we have the pickup and drop off latitude and longitudes, we have to use this to calculate the distance of the Uber ride. And then we can add this particular information to our data frame in pandas to better sort of understand how the fare has been computed. I mean, this is just a formula, so there's not much I can explain here. You'll just have to memorize it pretty much. Now we'll apply this to our data frame and create a new column called dist for the distance. And now we'll make the correlation matrix using a heat map. But for that we'll have to include the fair amount again. I actually didn't add it before. After this we'll get like the correlation between distance and fair amount, which we can use for our model. We've used a box plot for outliers over here, and I think I'm going to restrict the upper end to 250 instead of the IQR because there are so many points outside. Now we'll just split our X and Y columns, and let's build our linear regression model. We'll now import the error metrics and we'll grade our model like basically the errors. So as you can see, linear regression does pretty bad, but k-means clustering will actually do much better than this because it can spread out across like the data set. Linear regression has to go in a line, right? As you can see, the random forest model is way better than the linear regression model by comparing the scatter plots itself. Moving on to the questions that are asked in the oral examinations, these are the common questions which I'm sort of hoping will be asked. Again, I am not leaking any examination questions. I'm just trying to suggest what could be asked. So let's just keep that in mind. But yeah, my friends who have already gone through the oral examination think that these questions could be asked to other students as well. I can neither confirm nor deny that they have been asked these questions. But yeah, we'll just go through them one by one. What is the difference between classification and regression? So, basically, this is what they've asked, just one line answers. Like the output variable is categorical, the output variable is continuous. Then, what models can be used to predict housing prices? This was a question that I think could be asked. Uh, so the right answer for this is linear regression and random forest regressor. One is a model which assumes a linear relationship, and the other is a better approach which uses ensemble learning, and it has improved prediction accuracy. So you should suggest this one. I strongly recommend you to say that this as well. Then the types of regression, you have linear, multiple, polynomial, ridge regression, lasso regression, and logistic regression. Just a basic, description of each of them. That's more than enough, I think. Then what is the R square method? Now just go through this once. You just have to describe it in as an overview. So nothing in depth, because obviously you're giving an oral. You don't have to draw it on pen and paper. So yeah, I mean, one indicates a perfect fit and zero indicates no variability in target variable. So yeah, so basically R square means that more the R square score, better the regression model. And yeah, this was another thing which can be asked, which is basically, what about the data set? What data set have you used? What are the rows and columns of the data set? What is the nature of the data set? This is, again, something that's general. So this is not something specific to just this program. It's for applicable to all machine learning programs altogether. Program 2, Email Spam Classification. Classify the email using the binary classification method. Email spam detection has two states, the normal state and abnormal state, basically not spam and spam. So we've instructed to use KNN and SVM to classify these and then analyze the performance. Again, we'll start with importing the libraries and loading the dataset. All of these programs are available on the GitHub repository, by the way, link in description. Right, over here I messed up the path for this, so we'll just correct that. But yeah, the dataset seems pretty clean actually. Like it doesn't really have any, null values. So we'll just head on forward. I'll just remove the email column as it's kind of irrelevant over here. Also, please note that I'm using access equals 1 over here. Yeah, and we'll just now simply split our dataset as we did in the last program. You can do an 80-20 split or a 70-30 split as well. Basically, the larger part goes to the training and 20 or 30 for testing. Then you can import KNN from the scikit-learn module. And yeah, we're just writing classification report and confusion matrix because this is a classification problem, right? Yeah, the same we'll do for SVM as well moving forward. You can see that uh, the accuracy and this is visible for the both. Right, so now we will start with the SVM. We'll first of all import it from scikit-learn. Then we'll here I'm using kernel as linear. You can experiment with the different types of kernels, so that's up to you. Whichever gives you the better result, you can use that easily. Then we just fitted it to the training and training data, and we used prediction to basically test the data. Now, once it's trained, we can look at the confusion matrix and the classification report. And the examiner may ask you to draw graphs or heat maps for this, basically just to show the entire confusion matrix as a graph as well. So if that happens, you can use sns.heatmap and just display that clearly. Okay, let's talk about the questions asked or the questions that could be asked for the oral examination. The first one is difference between KNN and SVM. So just go through this once basically KNN is a lazy learner, SVM is an eager learner. It builds the model by finding the optimal hyperplane, but over here it doesn't build a model during training, but classifies new data points based on majority of its k nearest neighbors. Okay, then the three types of distances that can be used to basically find KNN, the clusters. They are Euclidean distance, Manhattan distance, and Minkowski distance. As far as I think if you answer one and two, that's more than enough. It's not necessary to know Minkowski distance, sorry. Then what are kernel functions and the types of kernel functions? So this is something that I think can be asked. Yeah, and just basically take a look at the kernel functions which are available. Linear kernel, polynomial, radial basis function or Gaussian kernel, and sigmoid kernel. Right? It basically elevates or allows to transform or project higher dimensional spaces and basically find a hyperplane over there. And then, yeah, what is a hyperplane? So again, you can look this definition up, but it's basically a plane which splits two or more data clusters in the most optimal manner, basically maximizing the margin between the two clusters and all the points. These were some of the questions that I think can be asked. Program 3, ANN Bank Churn. Given a bank, build a neural network classifier that can determine whether or not they will leave in the next 6 months. So we have to consider these 14 distinct features and then make a neural network which will predict whether they will leave or not leave in the next 6 months based on probability. So we'll start off by importing our libraries and reading a dataset. Also note that this program will require us to build a neural network using TensorFlow. So please request your lab assistant to let you install it in case the package has not been installed yet. The columns row number, customer ID, and surname in the dataset are not really required. So we'll remove those. Then we can encode the categorical variables, right? Using the label encoder. Because gender and geography are two categories that we can easily encode. So let's just do that right now. Also now we'll take our x and y variables and split them. And start the process of basically creating our training dataset. Now, one thing to note is that sometimes I use df.drop for the x and y, and sometimes I might use the double brackets as you might have observed in previous programs. Just note that they are interchangeable. Do not use single brackets as that will give you a dimension error. Now we will create a TensorFlow model and train it. I've kept my model, quite simple as PhD computers cannot handle a lot of compute. But this model also will deliver quite decent results. So we'll just start making a model right now. Okay, I forgot to mention, I have not installed TensorFlow. Just so you know, this is the type of error that we will receive. So you can use this command if it's not installed after asking them to, allow you internet access. This is what can be done. So now I have the TensorFlow thing installed. It will just take a little bit time to import because TensorFlow is a big library. Right, so I'll just enter my model now. Okay, I wrote an equal to sign over there by mistake. I'll just remove that. Yeah, and the model has been compiled. I've used binary cross entropy over here Because during training, the cross entropy loss function exponentially increases the penalty for wrong outputs and drive weights and biases more aggressively in the right direction. After the model has been trained, you have to convert the probability of the person leaving into a yes or no, which can be done using this statement, where we basically are saying that y should be greater than 0, using that as a threshold. And now you can see that the accuracy score is quite decent. 86% is quite good. This is a classification report which we've generated by using the zeros and ones we got from the probability itself. I just named put the format as 0f, 0.0f, so that only whole numbers are visible. Yeah, so this is our final output. So coming to the questions for program 3, I personally found that this is quite a rare question to come by. Uh, I have not really met anyone who was able to, tell me that they have actually gotten this question. So there's not really a lot of information about what type of things are asked, but these are some of the basics for that question, which I think could be asked. Again, just because they are basics, it's more likely that these questions will definitely be asked. So yeah, you can just go through them. Machine learning, types of machine learning, what is supervised and unsupervised machine learning, and yeah, what are we using in this project? What is the target variable? This, and then what is dropout? Since, if your model does use dropout, our model does use dropout. So this question can be asked, that what is dropout and what is the basic use of dropout. Okay, that was a lot to take in. Take a breather. Look at this Call of Duty footage that I recorded a few years ago.
Enemy down! Changing mag! I'm hurt! Target's inside! Target's inside! Enemy contact!
Sentry gun ready to deploy.
Need backup!
We've taken the lead.
Enemy!
XS-1 Goliath is ready.
I hope that was a bit refreshing, or maybe you felt a bit annoyed that I was spawn camping. But anyways, let's move on. Problem 4, Gradient Descent. Implement gradient descent algorithm to find the local minima of a function. For example, the function over here which we are going to do is y equals x plus 3 the whole cube from the starting point x equals 2. So first of all, this is probably the easiest program you can get in machine learning, but also pretty tricky questions can be asked for this. So we start off by defining the function y equals x plus 3 cubed, and we also define the derivative for this. Sorry, this was y equals x plus 3 squared, not cubed. But basically we define the derivative for this as well, which is 2 times x plus 3. Now we have written a function over here which basically takes the starting x, learning rate, and max iterations or number of iterations. What we basically do is we subtract the product of the derivative and the learning rate, which we subtracted from x itself. So we update x continuously, and then this happens num iteration times, and we append the value of x to the list, which is grad descent. So this basically gives us our value. The starting x is supposed to be 2 because the problem statement says start from 2. Right? We got the local minimum as this at this point, and now we can just plot a scatter plot for this. So that will basically show the descent. And over here you can try various number of iterations where you can experiment from 10 to 1000 and basically figure out how the gradient drops. You can change the learning rate as well to find how the learning rate actually affects gradient drop. Also, this error is happening the two graphs because grad descent is not reset if when we rerun the cell. So yeah, we rerun the function cell as well and everything is normal. This is how the graph will look if we do 1000 iterations with the same learning rate. So yeah, learning rate is 0.01. Now if we change the learning rate as well, you can see that the graph will also change and now it will be almost like a straight line. Basically, the way you change your learning rate and the number of iterations, your gradient descent will also change automatically. Let's take a look at the questions asked in the oral examination for gradient descent. These questions, I think, are the most probable ones that could be asked. So, what is gradient descent? Is one of the most common ones, I think. Then the types of loss functions, MSE, MAE, binary cross entropy, categorical cross entropy, and hinge loss. These are the types of loss functions that can be used in the model compilation. And what are the various types of optimizers? So as you know, Adam is the most common one, but these are some which can be asked. Again, since we are talking about learning rate and the this thing gradient descent, these types of questions I think will be asked. Now, is it possible to change the learning rate dynamically? I think this is something which may not be asked at all, but this is something which is in the syllabus, so it's better to be prepared about this. So yeah, the basic answer is step decay or exponential decay is something which can be used for dynamic learning rate decay as well. So reducing the learning rate gradually. Problem 5. K-means clustering. Implement K-means clustering or hierarchical clustering on sales data. Determine the number of clusters using the elbow method. So we'll first of all import required libraries and load the file. Please note that over here the encoding parameter needs to be set to Unicode escape in order for the pandas function to read the dataset correctly, or else it will give you an error that pandas was not able to render this file. So yeah, see, I've used Unicode escape as the escape like the character. Now, assume that we are clustering based on sales, quantity ordered, and price each. So we will scale them using standard scaler and we'll consider them as X. Now, the elbow method is a technique used to determine the optimal number of clusters in k-means clustering. What you have to do here is run k-means clustering algorithm a couple of times, like with k as 1 to 10 or 1 to 20, whatever you want to. Then plot the graph of k versus inertia using the coefficient inertia in k-means.inertia. The point where there's a sharp decrease in the decline rate of inertia is your elbow point. Now, what does inertia actually even mean? Inertia stands for within cluster sum of squares. It's basically a mathematical function where you find the sum of squares within the given cluster from the centroid, and it represents how well the clusters formed by the k-means algorithm fit the data points. Specifically, inertia measures the sum of squared distances between each data point and the centroid of the cluster which it has been assigned to. So, like I said before, we will use this elbow point that we got. In this case, I think we get 3 or 4. So we will use that and we'll basically see it on a graph. Yes, so over here you can make out that it's actually 3 or 4, something in between. Now I can't really tell, so we'll try to do it using both if possible. As we can see from the graph, our optimal K is 3 because that's where the sharp sort of decrease in the rate of decrease happens, if that makes sense. We'll just take a look at this updated graph right now. Now we'll use the k-means clustering algorithm to actually form the clusters of the given this thing data. Now we'll plot the centroids as well over here. So what I'm doing is I'm storing all the labels, centroids, and the x and y variables also. And yeah, see, this is how it looks with 3 clusters. Now we'll try it with 4 clusters as well. So this is how it looks with 4 clusters. Now, one more thing which we have to do is calculate the silhouette score for this. So that will actually tell us how good our model actually is. So we can actually use 3 and 4 over here to compare which one is actually giving us better results. Right, so if 3 gives us better results, you can go with 3 and say that for this, 3 is an ideal elbow point. If 4 gives us a better result, you can say that 4 is an ideal elbow point, right? Also, now we've considered the clusters as 3, and this is the silhouette score we get. Let's take a look at the oral examination questions for k-means assignment. So what's the difference between k-means and KNN? Again, k-means is unsupervised, KNN is supervised because there is a training over there. It's just that it doesn't do anything in the training. It just forms clusters based on the distances. K-means is used for grouping and KNN is used for prediction. So these are the two major things we need to understand. Then what is k-means clustering and hierarchical clustering? So this is something that is in the syllabus, but or I think this may not be asked. What is inertia or WCSS? Within cluster sum of squares is actually called inertia. So this is basically the sum of squared distances between each point and its respective cluster centroid. Right? Then the elbow method. We've gone through this in our assignment as well, but yeah, this is something that can be asked. What is the silhouette method? You might recall in our assignment we have a silhouette score. Basically, higher the silhouette score, better the clustering performance. It basically just tells us how well each data point fits within its assigned cluster compared to other clusters. And I think with that, we can wrap up this video. These were all the 5 machine learning assignments explained along with their viva questions. I hope you were able to find something valuable out of this video. If you have any questions, feel free to comment down below. Thank you.